Hello everyone, this is the third lecture on limits. So, in the last lecture, towards the end of the last lecture, we started discussing about infinite limits. So, let me continue with that. So, let me recall what do we mean by infinite limits. So, definition: we say that limit of f of x as x approaches a is equal to infinity if given any positive real number m, there exists a positive delta such that f of x is bigger than m whenever zero is less than mod of x minus a is less than delta. So, that is f of x can be made arbitrarily large by choosing x to be sufficiently close to a, but not equal to a. So, let us try to understand this with an example. So, for example, consider f of x is equal to 1 by x square, and this function is not defined at x equal to 0, but it is defined for all x non-zero. Now, let us ask what is the limit. So, what is limit of f of x as x approaches 0. So, what we see is that 1 by x square, if I take x to be a very small positive or negative real number, then 1 by x square becomes a large positive real number. So, the claim is that limit of f of x as x approaches 0, this is equal to infinity, and we will prove it using our definition. So, to show this, what we have to show is that given any m positive, we have to find a delta. So, let m greater than 0 be given, we need to find a delta greater than 0 such that if x minus 0 mod is bigger than 0 and less than delta, then f of x should be bigger than m. Now, what is f of x? So, but f of x bigger than m, this means that 1 by x square we want to be bigger than m, which is equivalent to writing that x square is less than 1 by m, and which is equivalent to mod x less than 1 by root m. So, we see that if, so therefore, let us take delta to be equal to 1 by square root of m. Since m is positive, I can take square root of m. So, this is a positive real number. Now, if mod x is less than delta and x is not equal to 0, then x square is less than delta square, which is equal to 1 by m, and this implies 1 by x square is greater than m, since x is not equal to 0, and this is our f of x, that is f of x is greater than m if mod x is less than delta and x is not equal to 0. So, this proves that, so hence limit of 1 by x square as x approaches 0, this is equal to infinity. So, as we have seen that we can define the left hand and right hand limit. So, similarly, like in definition, we can define the left hand or right hand limit to be infinity, which will mean that so we say limit of x going to a minus f of x is equal to infinity, or respectively limit of x going to a plus f of x, which means the right hand limit is equal to infinity if given any positive real number m, there exists a delta. This delta might depend on m, this is positive, such that if we have x to be, so for the left hand limit we are only looking at the interval to the left of a. So, if x is less than a and greater than a minus delta, this should imply that f of x is greater than m, and for the right hand limit respectively, if x is bigger than a and less than a plus delta, then f of x should be bigger than m. So, for example, for the function f of x equal to 1 by x, x not equal to 0, the right hand limit x going to 0 plus of f of x is equal to infinity. Why is this? So, proof, let m bigger than 0 be given, we have to find a delta positive such that if x is greater than 0 and less than delta, this should imply f of x equal to 1 by x, this should be greater than m. So, what should be delta here? So, let delta to be equal to 1 by m. Since m is a real number, positive real number, this delta is a positive quantity, and then if x is bigger than 0 and less than delta, which is equal to 1 by m, then 1 by x is bigger than m. Hence, the right hand limit at 0 of 1 by x, this is equal to infinity. Similarly, we will define the limit to be negative infinity. We say limit of f of x as x approaches a is equal to negative infinity if given any negative integer. So, any n less than 0, there exists a delta positive. Again, delta can depend on n such that f of x should be less than the given negative number whenever zero is less than mod x minus a is less than delta. So, for example, so let me write similarly. We can define the left hand limit of f of x equal to minus infinity and right hand limit of f of x to be equal to negative infinity. So, let us again look at the example f x equal to 1 by x. So, we have seen that the right hand limit of this f of x at 0 is equal to infinity. What about the right hand? What about the left hand limit? So, claim is the left hand limit of f of x is equal to negative infinity. This should again be clear, because if x is a negative real number, then 1 by x is also negative, and if you take x to be a negative real number which is very close to 0, then 1 by x will be a large negative number, right. But rigorously, if we want to prove, then let n less than 0 be given, then you have to find delta such that if so let me write quickly. So, take delta to be equal to minus 1 by n. Note that we need delta to be a positive real number. So, 1 by n is negative. So, minus 1 by n, this is a positive real number, and if n is large negative number, this delta will be a small positive real number. Now, if delta is equal to minus 1 by n, then if we take, so if my x is to the left of 0, that means x is less than 0, but it is greater than 0 minus delta, that means that x is greater than minus delta. This implies what? X is greater than minus delta which is equal to plus 1 by n. Okay, so, if we have x to be a negative number and greater than minus delta, then x is greater than 1 by n. Note that this 1 by n is, this is negative. So, this implies that minus x is less than minus 1 by n, and since x is less than 0, minus x is greater than 0, and now this minus x, this is positive. So, this implies that 1 by minus x, this should be greater than minus n, and which implies that 1 by x should be less than n. So, if x is less than 0 and greater than minus delta, then f of x equal to 1 by x, this is less than n. Hence, the left hand limit of f of x is equal to minus infinity. Okay, so now let us see. So, we have seen what do we mean by the limit of a function to be positive infinity or negative infinity. Now, let us see some properties. So, first, suppose we have f x and g x are two functions, and suppose the limit of f of x is equal to infinity and the limit of g of x at a, this is equal to some L which is a real number. Then what is limit of f x plus g x? So, this again must be equal to infinity. So, if we have the sum of two functions where the limit of one function is positive infinity and the limit of the other function exists and is finite, then the limit of the sum has to be infinity. So, to remember this, so we can write as a notation, if we have any infinity plus a, this is equal to infinity if a is any real number, right. So, whenever we have limit of the form infinity plus a real number, that has to be infinity. And this should be very obvious. The proof is we have to show that the limit of f x plus g x is equal to infinity. So, let m greater than 0 be given, then we need to find a delta positive such that mod x minus a less than delta and x not equal to a. This should imply f x plus g x should be greater than m. But we are given that the limit of f x is infinity and limit of g x is L. So, since limit of g of x is equal to L, by the definition of this limit we know that there exists some delta 1 positive such that mod x minus a less than delta 1. This implies that mod of g of x minus L is less than 1. So, note that what we are doing is here choose delta 1 positive corresponding to epsilon equal to 1. So, what we know is that limit of g of x as x goes to a is equal to L. If given any epsilon positive, I can find a delta such that whenever mod x minus a is less than delta and x not equal to a, then mod of g of x minus L should be less than epsilon. So, in particular I have chosen epsilon to be 1. So, mod g x minus L is less than 1. So, therefore, mod x minus a less than delta 1 greater than 0, this implies that g of x is between L minus 1 and L plus 1. So, this is one we get. Also, we are given limit of f of x as x approaches a is equal to infinity. So, for any positive real number, I can make f of x to be bigger than that real number for x to be. So, there exists a delta 2 positive such that f of x is greater than, let me write here m1 and I will write what this is later. So, f of x is greater than m1 whenever mod x minus a is less than delta 2 and greater than 0. So, now what happens is we have to look at f x plus g x. So, if we take delta to be minimum of delta 1 and delta 2, which is again a positive quantity since both delta 1 and delta 2 are positive, then mod x minus a less than delta and greater than 0, this will imply that f x plus g x. So, because mod x minus a is less than delta, which is less than delta 2, f x is greater than m 1 and mod x minus a is less than delta 1 also. So, by 1 this is 1, this is 2. By 1 g of x is greater than, we know, L minus 1. So, but what we want is that we want f of x plus g of x to be greater than m, where m was the given positive number. So, let us write this is equal to m, this is by 1 and 2. So, what should be our m 1? M 1 is equal to m plus 1 minus L. So, if I choose m 1 to be equal to m plus 1 minus L, then we can make f of x to be greater than this m 1 whenever mod x minus a is less than delta 2. So, hence the limit of f x plus g x this is equal to infinity, right. So, let me say that this rigorous proof might look little bit complicated, but you should understand the idea that if the limit of f x is infinity, that means that you can make f x to be as large as you want by choosing x to be sufficiently near a, and because g of x the limit is finite. So, that is near some finite number, and therefore, the sum can again be made as large as you want. So, similarly, let us ask what happens if both the limits are infinity. So, if limit of x going to a f of x is equal to infinity and limit of g of x is also infinity, then again the limit of f x plus g x, this will be equal to infinity. Again the proof is, let m greater than 0 be given, then let me write quickly. So, there exists delta 1 greater than 0 and a delta 2 greater than 0, such that mod x minus a less than delta 1 greater than 0. This imply f of x is greater than, let me choose half of m, m by 2, and if mod x minus a is less than delta 2, then since g of x the limit is also infinite, I can make g x to be bigger than m by 2 for this, and then by taking, so take delta equal to again minimum of delta 1 delta 2, this is positive, then mod x minus a less than delta greater than 0, this implies f x plus g x has to be greater than m by 2 plus m by 2, which is m. So, therefore, the limit of the sum is again infinity here. Similarly, you can ask suppose limit of x going to a f x is equal to infinity, then what can I say about the limit of x going to a of a constant c times f of x? is it equal to infinity? So, what we will see is that this is equal to infinity if C is positive, this is equal to negative infinity if C is negative. Okay, if C is 0, then C times f x is 0. So, of course, this is equal to 0 if C is equal to 0. So, why is this? So, first case 1, if C is positive, then let m greater than 0 be given, then m by C is also positive because C is positive. So, therefore, since limit of f x is infinity, there exists delta positive such that mod x minus a less than delta. This implies that f of x is greater than this number m by c, and this implies c times f x is greater than m, again because c is positive. So, that means that the limit of c times f x is equal to infinity. If c is negative, then we cannot write m by c, that is not positive. So, then minus c becomes positive, and therefore, if we have n less than 0 is given, then if I write n by c, this becomes, so if I write n by minus c, this is again negative because n is negative and minus c is positive. So, n by minus c is a negative real number, that is n by c, this becomes positive. So, since the limit of f of x is positive infinity and n by c is a positive real number, we can find a delta greater than 0 such that mod x minus a less than delta. This implies f of x is greater than n by c. What I have to show is that c times f x, the limit is negative infinity. That means that I have to show that c times x f x is less than n if we have mod x minus a less than delta. This is equal to minus n by minus c, and since minus c is positive, we can multiply both sides by minus c. So, minus c times f of x is again greater than minus c times minus n by minus c. That is minus c f x is greater than minus n, and which is equivalent to writing c times f x is less than n. So, therefore, by the definition, limit of c times f x is equal to minus infinity. And the last case, of course, for c equal to 0, c times f x is equal to 0 for all x, where f x is defined and so the limit of c times f of x has to be 0. Right. So, here you have to just be careful whether the constant is positive or negative to say whether the limit will go to positive infinity or negative infinity. Similarly, if limit f x is negative infinity, then the limit of c times f of x, this will be equal to negative infinity if c is positive, this will be positive infinity if c is negative, and 0 if c is 0. Okay, so we have seen that if we have sum of f x and g x, then we have some rule for the limit even if the limit is infinity. But one thing we haven't seen, so what can we say about limit of f x plus g x if limit of f x is infinity and limit of g of x is minus infinity. So, in this case what is happening is that f x is approaching infinity and g x is approaching negative infinity. So, it is of infinity minus infinity form. So, some of you might guess that this is going to infinity, this is going to minus infinity, therefore, infinity minus infinity is 0, but that is not true. So, let us see by some example. So, examples. One, let us take f x to be equal to 1 by x square and g x equal to minus 1 by x square, both are defined for x non-zero. Then here what we have is limit of f x as x approaches 0 is equal to infinity and limit of g of x as x approaches 0 is minus infinity, because g of x is nothing but minus 1 times f of x, and by our previous thing, because this minus 1 is negative constant, if we multiply then this goes to minus infinity. Now, what about f x plus g x? F x plus g x is 1 by x square plus minus 1 by x square, which is 0 for all x not equal to 0. right. So, this function is identically 0 in an interval containing 0. So, therefore, the limit of f x plus g x is equal to 0. So, you might be tempted to think that this is always true, but let us see second example. Let us again look at f x equal to, now I will take f x to be equal to 1 plus 1 by x square and g x is equal to minus 1 by x square, and both are defined for x not equal to 0. So, if we look at limit of f of x as x approaches 0, this is again the limit of the first function 1, this goes to 1, and the limit of 1 by x square is infinity, and we have seen that if we have the limit of a function is a real number and another goes to infinity, then the sum is again infinity. So, this is equal to infinity limit of g of x, this is minus infinity, but what about f x plus g x, and here f x plus g x is equal to 1 or x not equal to 0. So, therefore, the limit of f x plus g x is equal to 1 here, and there is nothing special about 1 here. If I change this 1 to any real number, so if instead of take f x to be equal to 1 plus 1 by x square, we take f x equal to some constant c plus 1 by x square, where c is any real number, positive, negative or 0, then the limit of f x plus g x is equal to c here, right. So, this infinity minus infinity, it can take any real number c. So, this infinity minus infinity, which does not make sense, this can be any real number. Also, so the question is, can it even be infinity or minus infinity? So, the answer is again yes. So, if we see, consider let us see f x and g x such that f x plus g x will be equal to infinity. So, if I take, this is again very simple to do. So, if I take f x to be equal to 2 by x square and g x to be equal to minus 1 by x square, then limit f x at 0 is infinity, limit of gx is equal to minus infinity and fx plus gx is 2 by x square plus minus 1 by x square, which is 1 by x square. So, we know that 1 by x square approaches infinity. So, limit of x going to 0 f x plus g x, this is equal to limit of 1 by x square x approaching 0, which is equal to infinity. And similarly, if we take by taking f x equal to 1 by x square and g x equal to minus 2 by x square, limit of f x plus g x this becomes minus infinity, because here f x plus g x is minus 1 by x square. Limit of f x is infinity and limit of g of x is minus infinity. So, what we saw is that this infinity minus infinity can take anything. So, the conclusion this infinity minus infinity is an indeterminate form, which means that you cannot decide beforehand what this limit will be. So, if one is going to infinity and another is minus infinity, then the sum it will depend from problem to problem what it is. It is an indeterminate form and can be any real number or plus or minus infinity. So, we have to carefully deal such limits. Similarly, another thing is that okay, so properties for product of functions. So, suppose limit of f of x is x going to some a is equal to infinity and limit of g of x is equal to some L, which is a real number, then what can I say about the limit of f x times g of x? So, we have seen a special case of this where g of x is just a constant, right. So, then we saw that it depends on the sign of the constant whether the limit is equal to positive infinity, minus infinity or 0. So, here what we will get is that this is equal to infinity if L is positive, and this is equal to negative infinity if L is negative. And we will also ask what happens if L is 0. So, if we have constant function 0 here, then constant times f of x, that is 0, in that case the limit is 0. But if the limit of g of x is 0, then that is more critical. So, question, what if L is equal to 0? So, we will answer these questions in the next lecture, and we will also learn about limits at infinity in the next lecture. Thank you.